Hi, welcome to YETI SMX. I'm Jamie.
And I'm Kevin.
And today we're going to talk about carbon chassis design. It's a tech talk about what happens here with the carbon chassis. So we're going to start with a few questions that a lot of people have been frequently asking us about the carbon, the strengths of the carbon, and try to dispel some of those myths. So first thing I'd like to ask Kevin is, walk us through the design from the shape, that shape to this shape, and why we changed the shape of this chassis.
Sure. So when we started out with this shape here, I was focused on just getting something that worked. We used a lot of thickness of carbon. We used a vacuum infusion process that allowed us, it's the process I've been using for 9 years building carbon fiber chassis for snowmobiles. We got all our strength from thickness, but we didn't use much shape. We got a little bit of shape in the top, gave us some longitudinal strength, but we didn't get strength into our attachment points. So coming over to this chassis, our current design, what we've done is now we've created a lot of shape in the chassis where each rib here creates some shape that took out a lot of the resonance that we had in this one. And same with here, it adds a lot of strength and no vibration. Also what we did is instead of having just thickness everywhere, we took and we added strength in right where we use it. So we have extra carbon that travels in our load paths, and that transfers all the loads from our suspension right up into the bike through our strut mount. And then the areas that have no load in them, they're all a smaller thickness. We use 80 thou in kind of the whole thing, but we're 140 thousandths of an inch thick in our drive areas and our support areas.
So it's done at the highest standard autoclave process, and it's also CNC trim. So each YETI that comes out is exactly like the next one. The process is tight. We check bearing fitment on everything and keep the consistent process. So that's awesome. So I was thinking, so we got strength by design. We talked a little about the thickness. How about the weight? Like, what are we talking about? What does this chassis weigh versus the ones we've been riding versus what the customer is going to get?
Yeah, sure. So these chassis right now are coming in about 12.5 pounds with this current laminate schedule. The ones we ride, we've built ones as thin as 60 thousandths of an inch for the whole chassis that weigh 8.5 pounds. And the one I ride is about half a pound heavier than that. And we've been putting them through the torture test. We haven't been able to break anything yet. We've had, extreme success with everything, and we're very, very happy with that. But we didn't want to release something like that. Ultimate weight, but for an extra 3 pounds, let's know that it's bulletproof and no one's going to have issues with it.
Yeah, so we went from 8 pounds to 12. And basically, we've increased the strength 2 or 3 times, maybe.
Almost 3 times at least, yeah.
So we've heard what the customers are saying, look, they're worried about carbon. How can you fix it, or how can I do it? It's going to crack, or it's not the right material. So we're going to have some videos later that you'll be able to see. And one is, where we take a forklift and we strap the chassis down. We just pull up with a forklift. We actually pulled up high enough that our scale tapped out at 1,200 pounds. The chassis flex, we let it down. We also have another test. We're going to show you how we just take a hammer, sledgehammer, just hit on the chassis everywhere, and how the carbon is flexible. Why don't you talk about the memory or the...
Yeah, so carbon being a monolithic material and the type of material that it is with the resin in it, it has no fatigue. So any steel, aluminum, anything that's welded, it'll work hard and it'll fatigue over time. Well, carbon doesn't do that. You can take a piece and bend it to this point of breaking, but not quite to it, and come back, and it'll always come back 100% to its original shape until the point of breaking, where once you go past that load, it'll break.
So you can flex it right up to the point of breaking millions of times, cycle it like an airplane with the wings flapping. It never breaks. But the first time you get to that point, the fatigue point, once you pass it, it breaks and it's done.
Right. Which in our case will be 3 times as much as it would be for a piece of aluminum or steel that someone else would use. So at a third the flex, it's actually going to bend and stay bent.
So it's the carbon is, even for me being new coming into carbon, it's been quite an experience, and to pick it up and go, geez, this thing weighs what? It weighs 12 pounds, and I can park my truck on top of this thing, and it won't break. It's very and even some of our early test riders, Corey's doing 60-foot drops with the YETI, and guys are like, was that thing going to last? Like you're going to drop off there, and he just does drop after drop. So there's a lot of real-world experience we've had the last 2 years of testing. And again, huge evolution in shape from one to the other, and not only the shape changed, but the strength of the unit designed, and it got lighter.
Great. And using FEA to see where our high stress load points were, knowing where we got to reinforce more and everything. So that all helps.
Yeah, so that's something else we can produce another video on and just show you the FEA testing. It shows, the flexing like you see an airplane wing. So,
Yeah.
But, keep your comments coming on the carbon. We're happy to share them and explain the myth. We're kind of like the carbon myth busters. So anyways, that's it today for carbon. Thanks for listening.
See you again. Thanks.
Talk to you later.